Welcome everyone. Let's begin our lesson for today by going over our learning goals and success criteria. First, what are we learning? We're learning how to utilize trigonometric functions of 30, 60, 90 right triangles and how to utilize trigonometric functions of 45, 45, 90 triangles. How are we learning it? Through the special right triangles notes and the special right triangles assignment. When can we use this information? To repair the roof of your house while making sure that the base of the roofing is flush with the house and the slope of the roof allows for water runoff. How do we know we learned it? By getting a score of 4 on the special right triangles assignment. Now let's take a look at our agenda for today. We will begin by going over our learning goals and success criteria. While we do that, you'll fill out your Get It Started. Once you've completed the Get It Started, we'll go over it together and answer any questions that you may have. After that, we'll go over the special right triangles notes, and then I'll give you time to complete the special right triangles assignment. Once you've completed the assignment, we'll go over it together and answer any questions that you may have. At the end of class, we'll go back over our learning goals and success criteria while you fill out your before you go. Your only homework for tonight is to continue working on the Reasoning with Irrational Numbers study guide and any incomplete assignments that you may have. Let's take a look now at the special right triangles notes. Our notes begin with the learning goals and success criteria. Now let's talk about what a 45, 45, 90 degree triangle looks like. So what this means is we're going to have our 90 degree angle here, and each of the other two angles will be 45 degrees. And because these two angles are exactly the same, that means that the side lengths opposite of them should be the same. So we're going to treat this as a unit. So this will be 1, and this is 1. So these two sides are the same. So now this side here, using the Pythagorean theorem, will be square root of 2. So 45, 45, 90 degree triangles tell us that we should have 1, 1, and square root of 2 as our side lengths. Now 30, 60, 90 degree triangles. So if this angle is 30, and obviously this angle is 90, that means that this angle here has to be 60 degrees. And the rule is that the side opposite of the 30 degree angle should be 1. The side opposite of the 60 degree angle should be square root of 3. And the side opposite of the 90 degree angle should be 2. So for a 30, 60, 90 degree triangle, we should have 1, square root of 3, and 2. Now if we know that this one's 60 and this one's 30, then this one's obviously 90. So the side opposite of here should be square root of 3. Side opposite of here should be 1. And this side should be 2. So that's how this would work with a 60, 30, 90 triangle. Now how do we use our trig properties on these? Well, if we have that this one's 45 degrees and this one's 1, we know that sine is opposite over hypotenuse. So if this is 45 and we have opposite, which is this case, we know it's going to be 1 and this is going to be square root of 2. So it's 1 over square root of 2. And now even though we didn't know what either of these sides were, because we know that this is 45 degrees, we know that this is 1 over square root of 2. Cosine now. Cosine is adjacent over hypotenuse. So the adjacent side, in this case, we do know that that's 1. And the hypotenuse now, because it's a 45, 45, 90, should be square root of 2. So it's 1 over square root of 2. Now we know tangent is opposite over adjacent. So we know that the opposite is 1. The adjacent will also be 1 because these should match. So we get 1 over 1. Now what if we scale it? So what if this side length is not 1? Well, all we do is we take whatever this is and we multiply it by whatever we're supposed to have. So in this case, this should be 1, but it's 4. So we multiplied 1 by 4 to get there. So we'd multiply this one by 4 and this one by 4 as well. And what we end up with is opposite over hypotenuse. So this side length should be 1, but we're scaling it by 4. So 1 times 4 is 4. So we should end up with our opposite being 4. And our hypotenuse should be square root of 2, but we multiplied by 4. So it should be 4 square root of 2. So we should end up with 4 over 4 square root of 2. Now here, we're doing cosine. which is adjacent over hypotenuse. So this side should be 1 as well, but it's 6. So we had to multiply 1 times 6 to get there. So we're going to multiply everything by 6. So this side should be 6 as well. This side should be 6 square root of 2. So when we do the cosine of 45 degrees, we should have 6 over 6 square root of 2. Now tangent is opposite over adjacent. So the opposite in this case is 8. It's supposed to be 1 though. So we multiplied by 8. So this side should also be 1 times 8. And this should be square root of 2 times 8. So this should be 8 and this should be 8. So we end up with tangent of 45 degrees is equal to 8 over 8. Now let's look at 30, 60, 90 triangles. So remember 30, 60, 90 should be 1 square root of 3 and 2. So remember that sine is opposite over hypotenuse. So we're going to take this opposite, which is 1, and the hypotenuse, which should be 2. So we end up with 1 over 2. Now cosine. Cosine is adjacent over hypotenuse. So if this side is 1, we know that this side should be square root of 3, and this side should be 2. So the adjacent side is square root of 3, and the hypotenuse is 2, so it should be square root of 3 over 2. Now tangent. Remember, tangent is opposite over adjacent. So the opposite side is 1, and the adjacent side should be square root of 3. So we should be 1 over square root of 3. Now what if we scale it? So this side here is 4, but it should be 1. So we multiplied it by 4. So now this side should then be 4 times square root of 3, and this should be 4 times 2, which is 8. So if we take the sine, remember sine is opposite over hypotenuse. So the opposite is 4, and the hypotenuse is 8. So we should get 4 over 8. Now cosine, remember cosine is adjacent over hypotenuse. So the adjacent side is here, and we scaled it by 6, so it should be 6 square root of 3. And our hypotenuse should be 2 times 6, which is 12. So we should get 6 square root of 3 over 12. Now this one we've scaled by 8, and we're trying to find the tangent, which is opposite over adjacent. So if this is scaled by 8, then we have to scale this one by 8 as well. So that's 8 times square root of 3. So we should end up with the opposite, which is 8 over 8 square root of 3. And those should be our answers. Now what if we're given the 60 degree here? So again, it's the same thing. This just becomes our 30 degree angle. So this is 1. This should be square root of 3, and this should be 2. So let's go ahead and do that. So now we want the sine of that 60 degree angle. So the sine is opposite, which in this case is square root of 3. And hypotenuse is 2. So we end up with square root of 3 over 2. Now cosine. Remember that cosine is adjacent over hypotenuse. So we're finding this 60 degree angle. This one's our 30. So 60 degree, the adjacent side is 1, and the hypotenuse should be 2, so it should be 1 over 2. And tangent, remember, is opposite over adjacent, so the opposite is square root of 3. The adjacent is 1, so it would be square root of 3 over 1. Now what if we were to scale these ones? Well, same thing. So this is our 30 degree angle, so the opposite of the 30 degree angle should be 1, but it's 4, so we're going to scale everything by 4. So this becomes 4 times square root of 3 here, and this becomes 4 times 2, which is 8. So the sine of 60 degrees then is opposite over hypotenuse, and the opposite side should be 4 times square root of 3, which is 4 square root of 3, over the hypotenuse, which is 4 times 2, which is 8. So we end up with 4 square root of 3 over 8. Now here, same thing. We scaled it by 6 this time. So now this side should be 6 square root of 3, and this side should be 2 times 6, which is 12. So cosine is adjacent over hypotenuse. So the adjacent side is 6, and the hypotenuse is 6 times 2, which is 12. So we end up with 6 over 12. Tangent is opposite over adjacent. So the opposite side, this time we scaled by 8. So the opposite side should be 8 square root of 3, and the adjacent side should be 8. So we get 8 square root of 3 over 8. There's a video here that shows you how to check side lengths using calculator.net, so you can go ahead and watch that video. Let's talk now about how you can check your work when finding the length of a side of a right triangle when you're given one side and an angle. So let's say that in this picture we're trying to find A, and we have B. We know that B is 3. And we know that angle alpha, in this case, this angle, is 60 degrees. Let's go ahead and we'll hit calculate. And it tells us what the lengths of each of the sides are and each of the angles are. So we can see that A, in this case, is 5.19615, or 3 square root of 3. And C is 6. We can also see that angle beta, this one here, is 30 degrees, and this angle here is 90 degrees. So we can use this information to help us solve for these different angle measures and side lengths. There's a video here that also shows you how to check angle measures using calculator.net, so you can go ahead and watch that video as well. Let's talk now about how to check our work when trying to find an angle measure of a right triangle. So in this case, let's assume we're given 2 side lengths and we're expected to find an angle measure. So let's say in this triangle we know that C is 6 and we know that B is 4. And let's say that we're trying to find angle alpha, in this case, this angle here. Well, we put it into the calculator. B is 4 and C is 6, and we hit calculate, and notice it's going to tell us everything else we need to know. So we can see that A in this case would be 4.47214, or 2 square root of 5, which is fine. That's not what we were looking for. What we were looking for was angle alpha. Well, we can see that angle alpha is 48.19 degrees. Angle beta, if that's the one we were trying to find, was 41.81 degrees. And we know that angle C here, this angle here, would be 90 degrees because it's a right triangle. So we can check and find any other missing information using this right triangle calculator. Let's take a look now at the special right triangles assignment. The assignment begins with our learning goals and success criteria. If we scroll down, we can see the questions. So we're supposed to find side X here, and we're told that this is a 30-degree angle, this is 90, which means this is 60. So using our rules for 30, 60, 90 triangles, it should be 1, square root of 3, and 2. So this side is 1, this side is square root of 3, and this side is 2. So our answer for X should be 2. So we'll go ahead and find that and mark that as our answer, which is this one here. And we'll continue to answer questions like this. Let's look at another one. We have a 45-degree angle here and a 90, which means this one's also 45. And our rules for 45, 45, 90-degree triangles is that we should have 1, 1, and square root of 2. So this is 1, and this should be square root of 2. So we'll go ahead and mark that as our answer. And we'll continue to answer all of these until we get to the end. Once we get to the end, we'll click Next. This will take you to your Before You Go. Go ahead and fill out your Before You Go and then submit your work on Google Classroom.